Hey, welcome back everybody. Today we're looking at 3-6, solving graphically with a calculator. So the first stuff is just kind of like algebra view. So we're just looking at the graph and determining the characteristics of it. So notice we have this graph in red or magenta. The first thing is asking us is f of 2 negative? So this is f of x, the red line. So what we're going to do is we're going to look at what is f of 2. So what this says is that when x is 2, what is our value for our function? So if we look over here, f of 2 right there is at 0. So this is no. It's not negative because it's 0. Alright, so it's asking us for which values is f of x equal to 0. So it's asking us, where is this red line equal to 0? So we found one of them already at 2. But we also have one at 0. And then we also have one at negative 3. Okay? And then it says, for which values is f of x less than 0? So this can be confusing. But what it's actually asking us is, where's the graph below the x-axis, right? Because those are all the places where the function is negative and therefore less than 0. So it's asking us to write an interval notation. So we're going to say from this point here, negative 3, all the way to 0. All that part there is negative. And we're going to use parentheses here because we don't actually count where it's 0 as where it's below the line, right? It's on the line, so we don't count those endpoints. It's weird in Alex, sometimes they don't recognize those parentheses, so if the parentheses don't work, then just put the brackets, these bracket things here. But it should technically be parentheses there. And also, we have another area here, let me change colors, where it's below the line. So that goes from 2 all the way to 1, 2, 3, 4, 5. About 5. Okay, again, we're going to use the parentheses because, well, actually, take that back. At the end here at 5, that's a point. And it ends there, so we're going to use brackets. The 5 is actually still below the line, so we're going to use the bracket instead of the parentheses. Because at 5, our graph is still less than 0, if that makes sense. Okay, for the next one, we're going to use the Alex graphing calculator to solve these. So we're looking at negative 2x minus 4 and x minus 3. So let's just go into Alex so I can show you. Let me write these things down before I forget. Negative 2x minus 4, x minus 3. Okay, so we're going to jump out of this for a little while. We're going to head into Alex. Oh, actually, let's just use the one that's already in here since it's in here. X plus 2 and negative 2x plus 7 are our functions. So let me write those down. So you're going to hit your calculator in the upper right. And what we're going to do is we're going to go to this. You see the calculator is in black. We're going to go just to the right of that where it says y equals. And that's going to allow us to input our function. So the first one is x. Where's my x here? It's hard to find. And it doesn't let me pull up my keyboard. Nope. Well, anyway, what you would do in here is you would put your two equations in, x plus 2 and negative 2x plus 7 in the second one for y2. So we'd have two of them. Let me show you what it would look like in Desmos then, but it's the same idea. You would do the same thing. Oh yeah, and once you hit that, once you put your things in there, you'd hit graph and it would show you your graph. Now you can also do it in Desmos. It's the same idea. So you would do y is equal to x plus 2, hit enter, and then we do the second one, y equals negative 2x plus 7, and what we're looking for is where these two lines intersect. So you can find them on Desmos the same way you do them on in your Alex graphing calculator, and we find that it's at 1.667, 3.667, 1.667, 3.667. So then you just go back here, and then you'd enter your coordinates into the boxes. All right, so yeah, a little bit of using technology. Once again, we're gonna go to y equals. You're gonna input your equation. Mine doesn't work too well on in the Alex because it doesn't pop up my keyboard. But if you find that problem too, you can also go to Desmos. In fact, Desmos's interface is probably even easier. You just put in your two equations, and then you find where the two lines intersect. All right, and then you put your answer into the box. Okay. These other two are in here. They're the exact same idea, but they're in a different form. So notice that we have this expression is equal to this expression, right? There's an equal sign in the middle. So they're in a different form as the first one we did, but we're going to treat them as if they're two separate ones because we can do that with the system. So you could say y equals 2 log x minus 1, and then y equals the other side of it, 2x minus 5. Right, so each side is a separate equation. And what we're going to do here is we're going to, well, let's do it in Desmos. You guys can do it in Alex if you want to, but it's just not working out for me. So 2 log x minus 1 and 2x minus 5. Okay. So we're going back in here, delete some stuff. 2, where's my log? Log x minus 1, and then the second one is 2x minus 5. 2x minus 5. Okay, and then we're gonna have to find where they intersect. Oh, these intersect at two places, right? So you can put 2.7410481, or you could also put 1.034 and negative 2.932. So those would be your two acceptable answers, and then you'd be done. All right, and then likewise for this, same idea. We're not going to go through it, but again, because we have the equal sign and we have two expressions, we're going to just say y equals the left-hand side and y equals the right-hand side. We're going to graph those two different equations, and then we're going to find where they intersect and just input it into your Alex boxes. All right, that's it for today. Hopefully it wasn't too bad. Hopefully you figured out how to use the graphing stuff pretty well. If you have any questions, please bring them to next class, and then we'll talk about them. And hopefully, if you have any trouble with the calculating or the Alex calculator or the Desmo software, then I can help you out then. All right, good job.